As electrified vehicles become more common around us, it's becoming more important to understand how it all works. So let's review some basic electrical terms and learn how they apply to this newest chapter in automotive technology. First, volts. Imagine water flowing through a garden hose. This behavior is actually very similar to electricity flowing along a wire. Now, say you block the end of this hose with your thumb. In electrical terms, the force of the water pressure now pushing against your thumb is voltage, which is measured in volts. The higher the voltage, the more push the electricity has. Next up, amps. Let's now stop blocking the hose and think about the amount of water flowing. In electrical terms, that rate is called current, and it's measured in amperes, or amps for short. Say you turn the water down to just a small trickle. This low flow rate would take a while to fill a bucket. But if we crank it back up, the bucket will fill quickly. The same is true when charging a vehicle battery. The more voltage and current we have, the faster we can fill a vehicle's battery. Unlike water, however, if too much electricity is flowing, the wire can overheat. That's why charging equipment incorporates safety devices that monitor the system to help ensure safe operation. Now, the third piece of the electricity puzzle is wattage, or watts. You've probably heard the term before, and in its simplest terms, it's just a measure of work. Basically, the amount of energy transferred in an amount of time, volts times amps. Think of a traditional light bulb. Its wattage rating is how much electrical power it needs to consume to operate, and the higher the watts, the brighter the light. This same principle applies to all electric products, whether light bulbs, microwaves, or electric vehicles. Watts are also used to describe battery capacity, specifically the battery's ability to deliver power during a span of time. In the case of an electrified vehicle, battery capacity is measured in kilowatt hours. This basically means that if a battery is rated at 1 kilowatt hour, it has the energy capacity to deliver 1,000 watts of power for 1 hour. For context, a typical vehicle only needs about 15 to 30 kilowatts to cruise at highway speed. So if we had a 60 kilowatt hour battery, we'd theoretically have up to 3 hours of highway cruising available, not factoring in variables like speed and outside temperature. Essentially, an EV's battery's kilowatt-hour rating can be thought of as the electric equivalent of a gas tank capacity, the energy stored on board that determines driving range. So now that we understand the general terms, let's talk about how electricity actually gets delivered. For this, we need to look a bit closer at current flow to really understand. Most standard power outlets provide alternating current, AC, which is also how it comes in from the electric company's power grid. As the name implies, AC rapidly flips the flow direction between positive and negative, and it's the best way to send electricity over larger distances. Batteries, on the other hand, work off of direct current, DC. They charge with DC and they output DC. And this is true whether for the AAA batteries in a TV remote, the 12-volt battery under the hood of a car, or the large onboard batteries used to drive the wheels of an electric vehicle. This also means that when charging a battery from an AC source, it must be converted to DC first. This conversion happens in that small power block at the end of your cell phone's charging cable. And it happens in the onboard system of virtually every plug-in vehicle that utilizes an AC power source. That's actually one reason why Level 3 DC fast charging can fill up an EV battery so quickly. By providing DC power to begin with, there's no onboard conversion needed. So that's a quick dive into some electricity basics. To learn more, visit toyota.com/electrified.